Hello, everyone, and welcome back to the 2018 Hack Summit. That was such an incredible session where we learned all about ZK snarks and ZK starks from the co-inventors of those technologies, Eli Van Sassen. And now I'm privileged to be here with Jutta Steiner, who was a former CISO of the Ethereum Alliance and has a company called Parity.io, which we're going to learn all about today, as well as have a great presentation that's going to educate us today. And she is joined by Jack as well on her team. And Jack, maybe you can kind of give everyone a little bit more about your background. I heard that you're kind of an early Rust developer, kind of the coolest kid in town, a core developer for Parity. Maybe a little bit more about you would be helpful as well.
I want to have it on the record that Jutta's the one that put coolest kid in town in that bio.
Well, it must be true.
Just me. I'm being vouched for. So yeah, I've been programming Rust basically since Rust was a released product, not before 1.0, but fairly soon after 1.0, and I kind of came into Parity as a result of that. I wasn't the blockchain dude until I came to Parity. I was a Rust dude that kind of fell into this space by accident. So, but now I like to think that I know something about blockchain, and that's what we'll be talking about
today. You get props from me for being in the Rust ecosystem. Mad respect for you for that. And Jutta, why don't you tell us a little bit more about kind of yourself and your background, how you got into blockchain, how you got passionate about this space. That way we can just learn a little bit more about you and see your smiling face before we go to your presentation.
Sure, cool. So I'm originally a mathematician by training. I spent quite a bit of time in academia, like mathematical physics, left after my PhD and worked for a couple of years initially as a business consultant for McKinsey. And then like really, so I guess what triggered getting like my interest in like not just blockchain, but like encryption and all these peer-to-peer technologies as well is really the Snowden revelations. I think that was when things just became, I got more and more interested in just understanding like how the web works and what it is that we're doing every day when we're online. And so I started to read about like decentral file sharing, what's available, and then accidentally came across the MadeSafe project initially, and then saw people discussing Ethereum in that context as well. And that was about 4 years ago, and then started to work for the Ethereum Foundation. I was looking after the security reviews before the launch. And then once Ethereum was launched, we just felt there's so much more stuff to do to build not just blockchain, but like all these technologies for the decentral web that we started Parity.
Mm-hmm. That's great. Thank you, Jutta. And so, Jutta, do you have any questions that you'd like me to ask the audience? That way we can.
I guess a quick poll, like what the background is. Like, I have like maybe the categories could be like students, business people, web developer, blockchain developer, and other. Maybe a quick poll.
Okay, so student, web developer, and what were the other ones one more time?
A student, web developer, a business person, a blockchain developer, or other.
Okay, sounds good. And audience, you might be in more than one category, so just try to pick the best category that fits your background. And I went ahead and submitted that poll now, so we should start to see the results start to come in real time here on the bottom of the screen.
Cool. And then likewise, like maybe a second one briefly,
Mm-hmm.
what the main interest is, whether it's like you have a particular business problem that you think you can solve with this technology, whether it's building a dApp, building a blockchain, or building other blockchain-related software.
I'm entering that now. And you can start to look at the answers already for that first question.
Cool.
So building a dApp, building a blockchain, and what were the other answers?
Building a dApp, building a blockchain, building other blockchain-related software. And then other.
All right. We always have to have an other. That's important.
That's important. Nobody should feel excluded.
Exactly. Okay, I added that as well. So we should start to see the results coming in. Yep, the answers are coming in right now. So what are you seeing here, Jutta, in the responses here? Anything standing out to you?
I guess it would now be interesting to see who the others are, but no, it's quite a from all the categories. That's good. So cool.
Great.
I think
But
relatively
Yeah.
relatively few blockchain developers, which I think is fairly good, because I
Yeah.
had aimed my talk at a relatively low amount of experience with blockchain.
Yeah, I think that's kind of what I'm seeing in the industry as well these days, is that there's a lot of folks who are curious about blockchain, but they haven't necessarily made the leap yet. And so maybe hopefully through this event, we can bring more developers into blockchain.
Sure, one can hope.
Great. Well, you guys can go ahead and start your presentation whenever you're ready, and I'll be right here.
Cool. Okay, I'll start the screen sharing in a second. Application window. There you go. Can you see the screen already?
Ah.
Yes. Okay, and I can toggle. Is it toggling for you? Okay.
Looks great.
That's good to me.
Cool. Awesome. Cool. Yeah, I start maybe a little bit more background on Parity. So as I said, like we build. Oops, that's a bit too fast. We started Parity really like coming out of this Ethereum experience, but back then already with this vision in mind to build like the stack for the decentral web, and that's like how our thinking over time evolved. I mean, like I started the company together with Gavin Wood, who wrote the original implementation of Ethereum and also the protocol, and I guess we weren't quite sure what it was that that we were building back then with Ethereum, and it only became like apparent to us also over time that this could be the backbone that replaces a lot of the infrastructure that we rely on in the future, and really sort of instead of like what we've seen so far, like where initially we had PCs and then we had intranets and then we had the internet, like in the future, what blockchains really provide is sort of this one emergent, like single computer or single computing environment where people can safely interact with each other, and which manages their expectations automatically without having to rely on any authorities. And that's really what we're trying to build here. And like throughout this presentation, like this, I would like to share a little bit of our learnings. How we think this space is evolving, like what are the components that need building. And then Jack, in the second part, he'll deep dive into one of the technologies we're building at the moment, which we see sort of as the third wave of blockchain tech. So if you think of, you had Bitcoin that let you, where everything was like tightly tied together. So it was like a protocol plus the currency, like all in one thing. And then with Ethereum, like this was like for the first time abstracted into the application layer and the consensus layer underneath. And then the technology that we're talking about later, Substrate, is sort of this next level, which lets you, which gives you like a really general framework for experimenting with blockchain technology. So yeah. So probably what you might have heard if you've Googled Parity before is the first thing we did as part of starting the company was a clean slate Rust implementation. We back then chose Rust, I guess, out of an excitement for a really efficient language that could make it really easy for us to build like safe applications. By now, this has evolved into a library or like into a suite that not only hosts the Ethereum blockchain, the public chain, but can do a lot more. And I go deeper into that in the following. One other thing that became, I guess, clearer to us over time, and it's quite an interesting thing to go back a bit in when you go on the Ethereum website and you look at like all blog posts, like a lot of discussions were around like, oh, will there be one single chain, multiple chains, like what's the competition landscape like? And like we believe that over what we've seen over time, like that the future will actually have like multiple chains that will interoperate with each other for particular use cases. I guess you've just seen, if you stayed online in the conference, like there'll probably be chains which are like fully encrypted, where you make this like trade-off of having a maybe a bit more of a slower chain, but instead, like on the other side, you get like a fully encrypted transaction history where everybody can safely transact with a peer without any information going out. And one of the things in that direction that we did was initially to sort of not just have the EFASH, like the proof of work algorithm, embedded into our code base, but instead have all this, have the consensus engine be pluggable. So you could use what we call a proof of authority system, for example, for private or consortium settings where each of the members would potentially host a node. That's one thing we did together with the, or that we're using at the moment together with the Energy Web Foundation in the context of decentralizing our energy systems. It's likewise been used for a public test network that we run together with other authorities, the Coven test network, and which is really our test bed for a lot of the innovative stuff that we're doing. And then some of you might have heard about like a major project that we did together with the World Food Programme, where we used the POA network as well to host a system that can be used to give out financial aid to refugees. And at least to my knowledge, like probably the biggest system in deployment at the moment. And it's been running very smoothly, sort of proves to me very much like how useful it is to harden your code base in this very hostile public environment before taking it then and using it and deploying it in a private network setting. Another thing that we did, which some of you might be aware, is actually a Bitcoin implementation, also in Rust, because, yeah, again, we're pretty excited about that language. And it's at the moment a small, like not that popular yet within the Bitcoin community, but we really hope that it will have a bit of uptake in the future, in particular using it as a basis as well for implementing Zcash, for example. A lot of the stuff that they do at this stage is in Rust, though like the underlying Bitcoin implementation at the moment still not. Yeah, so that's, I guess, like the first thing. So as I said, like we believe there'll be multiple chains for particular use cases, but then like an interesting thing that we think is needed in order to actually like have this safe like ubiquitous machine is combining blockchain with a lot of advanced cryptographic tools. So one of them being zk-SNARKs, what you heard about. Another thing that we've implemented is a technology called Secret Store. It's a threshold signature scheme that lets you store secrets or generate secrets and store secrets in a decentral way, which you can use in various settings. We've used it to build a decentral data store, and which brings me back to like where I come from, and which at the moment makes me really excited about like the space in general, because a lot of things are coming step by step together to build safer systems for people, where users have a lot more agency instead of having to rely on the central service provider. We also use this, and this is available in the Coven test network as well, for private transactions. So if you combine that threshold signature scheme with a POA system, proof of authority system, you can ensure that under certain security assumptions, both the code and the state of the smart contracts can be encrypted and only be read by the permission validators. Another thing that we are involved with is various scaling efforts, and I guess you might have heard of different ones. There's stuff happening on layer 2 for Bitcoin, for example, like Lightning. We are more involved in mostly in lower level things, but at this stage, another thing that's available is a technology called Parity Bridge, which lets you bridge several like Ethereum-like chains. Initially just for sending tokens, but like the second stage of this is to be able to send arbitrary transactions between the different chains. And that's really a powerful technology to scale a dApp at this stage, as you don't have to rely on the often congested public network, but you can instead sort of do most of the bulk and on a POA chain. Then, and that might be interesting, especially if you are like coming from a web development background, we are experimenting a lot also further up in the stack. In particular, one thing we are interested in is where will we in the end make the trade-offs between decentralization and centralization. Like one thing that we find particularly frustrating is that at this stage, the state of the Ethereum blockchain has become so big that syncing is actually an issue. Like even syncing on a relatively powerful machine on a desktop computer can be challenging. And so people, even for just sending tokens, rely on centralized services provider. And so one thing we're building at the moment is a light client that not just for mobile but also for increasingly, as I said, for desktop, lets you sync very fast to the Ethereum blockchain. The other thing is the Feather Light wallet. Like it's for us again an experiment to see what it takes to have an application, in this particular case, like a wallet on top of the Light wallet, and like optimizing on the user experience. And to not have to rely on, like say, Infura in the background, to rely on like centralized nodes that provide you with all the information about the state. Another thing, which is a nice little prototype, is a software you can install on any old smartphone that you don't use. I'm saying old, you can also use a new one, but it's nice, I guess, to recycle what you already have. And it provides you with a completely air-gapped device to sign transactions. So you basically download that app. You disconnect your phone from the internet or any other network, and then from that on, you use that via the camera and the screen to get information about a transaction into the phone, sign it, the keys then generated on the phone, and then get it outside, posted into the network. That now leads over to what Jack's gonna talk about. Like we believe a lot of standardization will be needed in order to help with adoption, and also security for that matter. Like lower down the stack, it's actually like a collaboration between Protocol Labs and us. It's a Rust implementation of libp2p for the networking of not just blockchain, but also other decentralized technologies like IPFS. The other thing that we've started last year is to use WebAssembly in several places to make them native to the browser, and also ensure, like, when we back then started Ethereum, like it made perfect sense to have like a custom-made virtual machine because it was like easier to engineer, integrate. You don't want to have mission creep when you build such a thing. But then when it comes to like getting actually adoption, making sure there are lots of tools available, resorting to standards makes a lot more sense to us. And then the other thing, like the big project we've started very recently, it's related to a new blockchain we are building called Polkadot. And Polkadot uses a technology called Substrate, which is really this general like sort of third wave technology that lets you safely experiment with new ideas, like be that sharding, new encryption schemes that come along, or governance, because it lets you integrate them in a dynamic way into what you're already running. And we use it in particular, as I said, in the context of Polkadot, where we built sort of our idea of how a future blockchain system, blockchain network of multiple chains should be run into this general framework. And if you want to learn more about what we're doing here, a few references. Also, if you're interested into like how you can make the transition into this space, like a lot of the people that we hired, and by now we're about 50 people, came similarly to, I guess, to Jack, like from a more sort of from the direction where they got interested in Rust, and through Rust heard about what we're doing, or they were initially, yeah, that's like one in route. But otherwise, like if you're interested in learning more, like feel free to reach out. Also, if you're not a dev and you're interested in how you can work with us, please feel free. And I'll stop that sharing now and hand over.
Okay, cool. Give me a second. I'll start the screen share. And so I'm going to be talking about one of the technologies that Jutta was talking about, Substrate. I'm not going to be talking about it in the context of having a common standard. I think it's important as part of that, and I will go a little bit into that. But for the most part, I'm just going to be talking about it as sort of, if you're an applications developer, you want to build something, then why this might be interesting to you. So yeah, I'm Jeff or Jack. I've been working at Parity for only about slightly less than a year, I think. And before coming into this, I had very little blockchain experience. I had heard of Ethereum, didn't really know why it was different from Bitcoin. And so I've geared this talk kind of at the me from a year ago, someone who maybe doesn't necessarily know so much about blockchain. So right now, decentralized systems in general. Decentralized systems are systems that don't rely on one central authority. So they're not common. They're not common at all. Pretty much anything that you use on a day-to-day basis, so your Facebooks, your WhatsApps, your Reddits, your Wikipedia, anything else. These things, they take content from all over the world. They take content from their users, but it's still a centralized system. Sorry, I'm hiding the chat so I don't get distracted. Even though you submit your content to them, they can do whatever they want with that content. I mean, we trust them to post it up somewhere. It's generally considered quite difficult to create new decentralized systems. You have to do a lot from scratch. You have to reinvent the wheel a lot. There's not a lot of abstraction. And this is kind of ties into why it's rare. I mean, it's generally considered not really a good idea to make something decentralized unless you have a really, really good reason. Like, for example, cryptocurrencies, like Bitcoin and Ethereum. I'm going to keep going back to Bitcoin and Ethereum because they're the names you've probably heard of. They kind of have to be decentralized because otherwise, if you have a central party, there's like a massive incentive for them to screw you over and take all your money. They're kind of hard to understand still for the average person. I think most people at least vaguely understand how a web app works, even if they're not even a developer. But most people don't really, not even most developers generally understand how decentralized systems work. I mean, you could probably count the number of people who could build a production grade decentralized system in the entire world on the hands of a large family. It's quite rare to find someone who really knows something good about how to build one, and you kind of have to do everything from scratch. So it is important that you really understand it. And I think a lot of people aren't convinced that there's a use case. I don't think many people really. I mean, I think there's like some people who are real evangelists for decentralizing everything, and maybe I'm a little bit of this, but I think most people aren't actually that convinced. So should you be convinced? What is the convincing arguments for decentralized systems and blockchain specifically? So the one that everyone brings up is censorship resistance. I think censorship resistance is super important. But I put it first because I think it's maybe less convincing than the other ones. I think a lot of people hear censorship resistance and they're just kind of like thinking, oh, great, here's another platform for the Nazis or the Klan or whatever. I think most people don't generally feel like they're in danger of being censored. But I still think censorship resistance is useful for the average person, because even if you want some amount of censorship in your platform, it is good to have a basis of resistance so that you can sort of have a marketplace for censorship. On top of that, you can choose what you want to hide and what you don't want to hide, rather than having this one centralized party making that choice for you in a completely impenetrable way, something that you might not know. You don't even know that they're censoring. So decentralized systems are very robust and they're very secure. This isn't so much like an innate property of decentralized systems as much as it's kind of like a Darwinian thing. Your decentralized systems or centralized systems, you can kind of make them not robust pretty easily, and it's kind of the path of least resistance. And making them not insecure is also the path of least resistance. Whereas in decentralized systems, if they're not robust and they're not secure, it's going to fall apart almost immediately. I mean, this might just make it sound like it's just another way of saying that decentralized systems are really hard and trying to spin it as a good thing. But I think there is something to be said for things having restrictions. Like making a mobile app has a lot more restrictions than making a desktop app. If you have sudo permissions on a desktop, you can install drivers, you can change the boot settings, you can do basically anything. I mean, if malware gets sudo permissions, that's complete game over. Whereas on a phone, you have like these very fine-grained permissions, and there's a lot less that you can do. But building the average app is still as convenient, despite the restrictions, because people can build abstractions with those restrictions in mind, and often they can be even easier to develop because the restrictions sort of let you make a lot more assumptions. Decentralized systems sort of give a real incentive to keep your code open. I mean, if your code has to run on everyone's computer separately anyway, why not make it open source? Why not let everyone hack on it? Because there's no real downside. You know, everyone's running the code anyway. Everyone has the code in binary form. And this also sort of allows better interoperability. You know, if everyone sort of understands how the system works, they can build more protocols on top of it. They can build protocols that interact with it. And that's great. Communism, everyone's favorite thing. Everyone loves communism. I'm going to make the communist argument for cryptocurrencies. I don't think you hear that very often. So I think that there's like something to be said. I mean, as much as I wish I had a beard as luscious as Marx, I do not. And so I don't think I can make strong arguments for communism as a system of government. But there's something to be said for shared ownership of systems. If you have a centralized system, someone's trying to extract value out of it, someone's trying to get something from it, at the expense of the users, there's kind of an antagonistic relationship there. Whereas a decentralized system, everyone owns it collectively. It is collectivized, if you will. And so there's no one person trying to extract value out of it. Everyone's kind of working together. And finally, this is what I think is really the heart of why decentralization is important and why it's something that we should be striving for, and why I'm somewhat of a weirdo as evangelist for it. You can sort of decentralize trust, you distribute trust rather than decentralize. Instead of, I mean, so some people call decentralized systems trustless, which is not technically true. You still have to trust someone somewhere. You don't have to trust the network, which is important. Even in Bitcoin and Ethereum, where in theory you don't need to trust, in theory it's trustless. I mean, if you're paying someone, you need to trust that the person's going to give you something back for it. You know, there's trust somewhere. But I think that having the system be completely trustless allows you to choose your own level of trust. If you're using Stripe to pay someone, you have to trust Stripe. You don't have a choice there. Whereas you can, so the way I see it is that trust is a very good optimization. If you trust something, you can make it faster because you can do less verification work and sort of just assume everyone's doing the right thing. And you can, in a trustless system, you can choose to take that optimization to trade some trust for some speed, or you can, if you're like the kind of guy who wears flannel and kills his own meat, you can also not trust anyone at the cost of some reduced speed. But what's the problem with decentralized systems now is building them is really, really hard. As I said before, everyone has to start from grade one. Grade one, step one. No one really knows how to make money from it. Apart, I mean, cryptocurrencies kind of make money, but everything else is running from donations, which isn't really sustainable in my opinion. It's kind of a rock star economy. We're still researching it. I mean, the internet is 50 years old next year. I think it's 49 years old this year. And it's still considered a young technology. And decentralized systems that are built on the internet is an even less, even newer field of research. We don't really know that much about it. And most decentralized systems are pretty user unfriendly. There's a couple of exceptions, but for the most part, it's kind of like a developer's game to use decentralized systems. We are not going to tackle points 2, 3, and 4. We're going to tackle number 1. That's what Substrate is for. Substrate is to try and make these systems extremely easy to make. As Parity, the company is tackling the field of research and the user friendliness, but Substrate is not. So Substrate is built to facilitate the Polkadot project. It's got a few sort of base goals that everything else is built on. The idea is to use Substrate, you shouldn't need to understand the entire research and the technology that backs Substrate. This is sort of, it should be conceptually simple. Like when you use a web framework to make a server, you generally don't need to understand everything about how HTTP works, how handshakes work, because that stuff isn't important. What matters is your business, your business logic, and the same should be true of Substrate. It should have a very minimal interface. The surface area should be small because we want Substrate to allow you to just describe the distributed application, and then for the backend itself to not really matter. And so that means you can deploy it on different backends. You can deploy it as a standalone application. You can deploy it on Polkadot, which is a sort of a blockchain for blockchains. I won't go exactly into it now. And it should be portable. So it should be, not only should it be compilable for different backends, but it also should be compilable like with no extra effort for Windows, Mac, Linux, and even the browser. By default, you shouldn't have to put extra work in for your application to run on these things, because every distributed application will need to run on all of these things apart from a very, very small number. So we want to make it as easy to write portable code as possible. So if you've heard about Substrate before, you've heard about it as part of Polkadot, but it's not the same as Polkadot. It's a related project in that Substrate is the backing. Like, so Polkadot is built with Substrate, which kind of, this is useful for us. It means we can get good feedback on Substrate and make sure we know where the holes are. Polkadot is a backend for Substrate, as I've mentioned. And Substrate was originally developed as a way to develop Polkadot. So it was like, we had the idea for Substrate before this, but it's being developed as part of Polkadot. But you don't need to know anything about Polkadot to understand the rest of this presentation. So how would you build an application with Substrate? I mean, I'm saying application here, even though, so, yeah, you write your application as a blockchain. Substrate is a framework for creating blockchains. And the idea is you write the blockchain logic, the thing that happens from block to block, and then Substrate handles all of the rest. It handles like sending messages throughout the system, communicating blocks to nodes, consensus, etc. I'll talk about exactly what it does later. So probably if you're not building a cryptocurrency, you turn off when you hear write a blockchain or you hear blockchain framework. I mean, it seems like a lot of companies nowadays are just like putting thing on the blockchain, and a lot of those are as dumb as you think. Don't worry, you're not going crazy. But blockchain is actually more than cryptocurrency. And I mean, really, a blockchain is just an ordered list of messages So we call them extrinsics. This is just because we want to keep the idea as generic as possible. We don't want to tie ourselves to transactions or even to messages. And I'm going to keep saying extrinsic for the rest of the presentation. And it's some state. And really there's nothing else. I mean, there's some modulo, some stuff with blocks, block headers. But really, the thing with block headers is just an optimization. You know, conceptually, it's just a list of messages and some state that responds to those messages. And I mean, you don't need to have transactions there. That's not and the state doesn't need to be a map from account to balance. I mean, in Bitcoin, Bitcoin actually has some extra state, but we'll just pretend that Bitcoin is a very simple cryptocurrency for now. In Bitcoin, each message is a transaction, move money from A to B. And the state is this account has this much money, this amount of money. But that doesn't need to be the case. I mean, a blockchain doesn't need to be that. So if you can build a system using the actor model concurrency, so that's React and Redux or Erlang, event sourcing is the same concept. If you can do that, you can build it in Substrate. I mean, most people understand this concept of message passing or reactive programming, at least a little bit. They've at least heard of it. So why would we want it to be a blockchain specifically rather than some other system that maps to event sourcing? So you get this event sourcing thing, but you also have distributed processing. The list of messages is chunked up into blocks, and you can pass it around everywhere, and then people can and then you get the messages processed on different computers, and you kind of get that for free. I mean, so if you just describe the way that the blockchain should work, which is what Substrate lets you do, you're basically describing the system as a whole, you know, as if the whole world was one computer. And the behavior of the actual individual nodes is kind of handled implicitly by Substrate, or by the backend that Substrate compiles to. So why is there only cryptocurrencies built with blockchain right now? Why is it not so common to hear about other things? I mean, so we have things which are not necessarily solely cryptocurrencies built on blockchain right now. Like Ethereum is a smart contract platform, but really everything comes down to money in these systems. So why is that? I mean, currently blockchains are super slow. I mean, anyone can submit a block at any time, which essentially means that, I mean, say you need 1 second to create a block, 1 CPU second to create a block, just to do the work to create it, ignoring the proof of work stuff, if you know what that is. But then because everyone's trying to submit a block simultaneously, if you have 100,000 people attempting to mine the block, then you have 100,000 CPU seconds being used to create a block, which really only needs 1 second to create. So in Substrate, we use what's called proof of authority. I mean, essentially, this means that for any given block, there's a set of authorities, there's a set of computers, a set of miners that could be chosen from to create that one block. And then only that one authority does that work to create the block. And then from then on, the other authorities that could have been chosen for that block then vouch for it later on. And this means that there's like there's a time when you know for sure that block can never be reverted. You know that it's now immutable. Whereas in systems where anyone can submit a block, because it's sort of open-ended, you never know if someone is just going to come out of the blue that you've never heard of before and submit a massive chain that then like invalidates the previous chain you had. So you're never 100% sure that a block is immutable. And like, so proof of authority is kind of, it seems like because there's this set of authorities that it might be less decentralized than something like Bitcoin where anyone can submit a block. But you can use proof of authority and build abstractions upon it. You know, you can have the authorities chosen by a vote, normal vote, or you can have it be chosen by like you put money in collateral. If you're building a chain that does have money, it is a cryptocurrency. You can put money in collateral, and then as a result, you put yourself on jury duty basically to create a block, and then you get some reward for just being willing to be on jury duty. And then if you actually get called up to create a block and you do it wrong, then the collateral money gets removed, gets slashed. And like you still have all the benefits of proof of authority, but also the decentralization of what's called proof of work, the Bitcoin system. And it kind of, as a related thing, Bitcoin and Ethereum kind of have to be inefficient for security's sake. If you could create blocks as fast as blocks could be created without this idea of like proving that you've done some amount of work, then the whole network would be flooded. There'd be reorganizations all the time. It's kind of proof of authority is a more civilized system. It you don't have everyone racing and trying to fight with each other, and so you don't need this like deliberate inefficiency slowing down the network. So even proof of authority, even if you don't have what's called proof of stake, which is what I was saying about like jury duty, even proof of authority is still more trustworthy than a centralized system, because if in a centralized system you have to trust one party, in proof of authority you only need to trust that no more than 1/3 of the authorities are working together for one bad goal. I don't know if that sounds too technical. So if that's too technical, but you, the point is that you, like any one party can't screw you over. You have to have a large collaboration, and even so, because it's because anyone can verify a block, because everyone's running the same code. You're running the same code as the authorities are. The only difference is that everyone agrees that the authorities are worthy to have created the blocks, and they will reject blocks that were not created by the authority. I mean, you're still running the same code. You can just run it as if you were the authority and see if you get the same result. And if you get the same result, then the authority's done the correct thing. And so as a result, like the number of things that authorities can do, even if they're working against the interest of the network, is quite small. Whereas like WhatsApp or Facebook can just do whatever they like. I mean, they could replace the entire database with pictures of ANC Harriet tomorrow if they want to, but you know, we assume they won't because that's against their interest, but there's nothing stopping them. Whereas in a proof of authority system, and especially a proof of stake system, it's not really feasible. But of course, trust is a good optimization, and you can choose to trust that the block is correct and trust that the system is working as intended. And you can just like skip all the work that you would have done to verify it. And so you get something that is as fast as a centralized system, modulo some caveats, but you get all of the benefits of a decentralized system as well. So there's, I mean, I don't want to say there's no downside, but the downsides that you typically associate with blockchains are massively mitigated by using this system. So hopefully I've convinced you that, you know, not only do blockchains not have to be for cryptocurrencies, but even if you are creating a cryptocurrency and you want to create a new cryptocurrency, that the way that Substrate does things is a better way of doing it than the sort of accepted law of how you would create a cryptocurrency nowadays. So what do you actually need to make? I mean, so number one, you need to create one function that creates a new block based on the previous block's header and the state that the system's in. Obviously, you can read and write the state. This, I mean, for a lot of things, this isn't even going to do much. So this, you need a function that handles a single extrinsic, basically a single message. I mean, if you're used to event sourcing, this is basically just like what handles a single message. This is what does all the real work, quote unquote. The stuff that the function that does stuff based on the previous block's header is kind of like an optimization. It's for metadata. The meat of the processing is done in this function, which handles a single event, message, transaction, extrinsic, whatever you want to call it. And then that you have a function that gets a block that's had the extrinsics processed and added to, and then it like seals it. It finishes creating it, and then it allows, and then it gives it back to Substrate to pass off to the network. And then for verification purposes, both in the authorities and in the verifying nodes, you can just have a function that takes an existing block and executes it all at once. I say optional because you could implement this as a function that recreates the block, like I was saying before, but like that would be very slow. So there's not really any reason to actually do that. It is important to not let this and the other functions get out of sync, but you'd extract stuff to common functions, so it's not actually that much of a problem in practice. And that's and apart from like stuff that sends messages to the blockchain, which I mean, depending on the complexity of the application, might be a different amount of complexity. But apart from that, that's really it. I mean, the sort of the heart of the application is just one function that handles events. The surface area of the substrate itself is just the 4 functions at the top. The application code is its own thing, and substrate has no way of caring what the application code is. It couldn't care if it wanted to. So what does substrate actually do for you? You get consensus. You get this global agreed upon system state, and it's unique and it's canonical, and it's past a certain point it's immutable. You could write a substrate application with consensus issues. It doesn't like prevent you from writing bad code in that sense, but the number of rules you need to stick to in order to get perfect consensus is relatively small. You get the networking code for free. So that's communicating between different nodes. That's sending messages to the network. It's quite a lot. You get a cross-platform storage abstraction. So that's not only across all the OSs, but also in browser, across all of the. It abstracts whether or not you even have a file system. If you want to, you shouldn't have to care about this as the developer of the application itself. So Substrate, which is, I mean, this, I would love to talk more about the client upgrades because I think it's really important, but you get a way to upgrade your client seamlessly. So one of the problems with blockchains right now is that every time you want to upgrade, you have to have a hard fork, as it's called, which means you have to give all the code to everyone and then assume that they're going to switch to the latest version on the right block. I mean, you do this automatically in the client, but it's still like, what if someone doesn't receive the update in time? Whereas this allows you to integrate that with the blockchain itself. You pass out the code in WebAssembly on the blockchain. So although it would be desirable for everyone to get the native code version, you at least have a WebAssembly fallback, which is on the blockchain itself. So every client will at least have the correct version of the client, even if it might not necessarily be the most efficient version of that client. And then the switching to the efficient version, if you have it, is also done by Substrate. You get a WebAssembly runtime. I mean, I'm not going to dwell on this too much, but Substrate sort of deeply integrates this. If you run Substrate. So Polkadot is built on Substrate and runs Substrate chains. Those Substrate chains also get the WebAssembly runtime, but it's not a WebAssembly runtime that's then written in WebAssembly. It's like all of them call out to the top level WebAssembly runtime. So it's sort of it's more similar to how Linux fork works, if that makes any sense to you. But I'm not going to dwell too much on this. But I think it's very important. You can use it to run plugins for the network or programs, or you can run smart contracts in a cryptocurrency. And when Polkadot's released, as I've mentioned a few times, you can then run your software, whether it's a cryptocurrency or not, on Polkadot, which means you can integrate with all the other things that run on Polkadot. If you want to create something that uses currency but does not have its own currency, you can do that. You can have it integrate with Ethereum or Bitcoin using Polkadot, and then have payment done that way. And it's all automated, and it's all has consensus across the whole network. So what could you build with it? I mean, so the obvious one, everyone thinks when they hear blockchain, they think of cryptocurrency. Obviously, you could build a cryptocurrency, but I think this is more important than it is obvious. So cryptocurrencies nowadays have a lot of problems, as I explained before, with the problems with blockchain, and a cryptocurrency built on Substrate would not have these problems by default. And maybe it has some other problems, but very smart people are working to fix these, and they haven't come to bear yet. And you get a better cryptocurrency by default. That you get an immediate unfair advantage if you're building the Substrate. You can build a message bus system. So if you know what Swift is for banking, it's essentially this centralized message bus where different banks can communicate with each other and make sure that they all know the same stuff. But they have to trust the Swift company. I mean, Swift is audited, but then that means you have to trust the government, which I'm sure banks do plenty. But the point is, it's sort of based on this centralized company which is trying to extract value. But if you have many different companies and they use like a substrate system where the companies in question are the authorities, they can still have this message bus, and they don't have to trust each other. They only need to trust that no majority of these companies are collaborating. You could make something like Reddit. If you wanted to, I mean, you could have something where like moderators act as authorities, since people trust that moderators are somewhat answerable for the subreddit, quote unquote. And you could also expect that moderators do the extra effort required to be an authority, because it's not like the average person could just connect with like the non-verifying clients, and then the moderators could have the authority clients. You could make a chat application that spreads across the whole world and is not censorable and is encrypted, if you're the kind of person who likes to get knocked on your door by the FBI. And likewise, you could create a marketplace using Substrate that uses other currencies rather than having to be tied to the currency of the chain that it's built on. But again, probably you're just going to get knocked on the door by the FBI. Anyway, if you want to hear more about this, follow us at ParityTech, paritytech.io, info@paritytech.io. I don't know who checks that email address, but I bet they have a really fun time. The Polkadot Network Twitter account, Polkadot.network, is the information on Polkadot itself, which includes the information on Substrate. And thank you so much for listening. And I think now we're doing a Q&A.
Cool. I've already tried to answer a few questions that came up. Are you moderating?
Turn the chat off, so I didn't
you can feel free to do that yourself. So feel free to jump in and pick out any questions that you think are interesting to answer.
Maybe I'll start with the one that was voted up the most, like on Cosmos, just as a comparison, Cosmos and Polkadot, because we're being asked that a lot. Like in terms of like both projects, like especially Cosmos aims at interoperability, but it does so only for tokens at this stage, while Polkadot goes way beyond like arbitrary transactions. Also within the Polkadot framework, one key thing is the relay chain that lets you pool security as well, and as such gives you a framework for also addressing scalability. Like by pooling the mining resource, you can have more chains that through the relay chain then interact, and you don't get the competition for this scarce mining resource. Any thoughts on why Go seems to be the preferred language? Not actually sure it is the preferred language. I mean, a bunch of projects use it, but we're seeing more and more of them moving to Rust, as I said, like with Zcash, for example. I guess it's sometimes easier to use. What's your opinion, Jeff?
So I think the Go is pretty popular in the cryptocurrency world because it is like very fast enough, and it doesn't have the security problems. And obviously, you need like great security. Well, it has. I mean, there's some foot guns in it, but like it's a lot safer than C and C++. So it's quite it's a lot harder to write very insecure code, which is obviously like really important in blockchain. And also, I think a lot of blockchain stuff is very easily parallelizable, which Go is quite good at. I would not say that Go is the better language for it, but I think there's certainly a lot of blockchain software built in it, and I think that's why.
Yeah. Difference between POA parity and POA projects, such as POA networks. POA networks actually use our POA, as far as I know. Like a lot of projects actually use our code base in what they deploy, especially for private networks. It's one of the most popular systems that people use. Obviously, they pick their own authorities because that's up to their up to them to choose. What else do we have? Substrate documents, when will there be more? I guess we're just starting. Like there was just a few days ago a blog post by Jeff on the topic. I mean, it's heavily building. Like we're still building it, so while we hope to have it ready for people to actually use over the course of this year, it's still being it's still under heavy development. What else do we have? What helps startups and projects to build more blockchain-based solutions? I guess it's like a lot of tooling that's needed for devs to make it really easy to build applications. And also, as I said, like if you then think of actually deploying your app, like unless you sort of host it or like then make the trade-off and let a lot of things in the end be centralized where you're the custodian, it's UX and UI. So there's a lot of challenges that need to be addressed. So if you're up for that, I think that's an interesting place to start actually as well, if you want to get into the space.
Do you want to talk about delegated proof of stake, which is in the chat right now? Someone asked about it.
Yeah, if you've seen, do you want to say something?
Sure. So I think delegated proof of stake has some problems, kind of similar to how the proof of work kind of leads to this getting richer centralization, like leading to centralization kind of thing. Delegated proof of stake kind of has a similar problem, I think, but there's also like a lot of internal politics, I think, within the delegated proof of stake systems of like delegators talking among themselves, because there's like quite a small number of known sort of not delegators, sorry, known authorities that you can sort of just go up to and ask about stuff, and so it's a lot easier to have this internal politics than in a proof of stake system where the authorities are more or less random, which makes it a lot harder for them to collaborate. That being said, I don't think it's completely worthless, and I don't think we've seen enough of it to really know how it compares to other systems. I don't know if you've got anything else, Jutta?
No, I think I'm good. Just in the interest of time, I'm wondering. Yeah, there's Ed there.
Great. I'm not sure if you're seeing my video. There might be a little glitch on my end,
yep.
but wanted to just thank you both for being here. It was very educational to learn about your new initiative. It's actually very impressive to me as a fellow entrepreneur to see just how much you've built and how many subsystems there are and all these different initiatives that you're in charge of. It's just an incredible contribution you're making to the blockchain industry. I just want to acknowledge you for that and commend you for all the help you're giving to developers around the world to onboard them on the blockchain, make it easier for them to get started. This is something that's sorely needed right now in the industry, and you guys are pulling it off. So thank you for that.
Thanks. Maybe just because I saw that question, like also with regards to how we're financing, I guess in that regard is also a really interesting space at the moment as we're trying to figure out like how to finance the building of infrastructure, like how do we collaborate, like partly we're paid for feature development by partners that use our software. And it's really interesting also to see like how tokens in this setting can be used to then also help with collaboration on a protocol level, which is much easier to establish than the traditional way of trying to negotiate a joint venture.
Great, thank you, Jutta. Well, it's been fantastic having you both here. I really appreciate your time. It was awesome learning from both of you. And audience, I think the audience has had a very similar response. Look at the chat. Everyone's thanking you and excited to learn more. So please visit parity.io, visit Polkadot, take out Substrate, play with it. It'll make your life a lot easier. And guys, we'll be right back in just a second here with Dominic Williams.
And join us in our riot channels.
Exactly. Join them as well. We're going to be right back with Dominic Williams, the CEO of Definity, who's created what he calls the Internet Computer, a revolution in blockchain. And we'll learn all about it in just a second. So hang in there, guys. And Jutta and Jack, thanks again for your time today. It was awesome having you.
Bye.
Thanks a lot. Bye.
Thanks.